Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of area of composite figures. This is 7.9C Readiness Practice, the intermediate version. If you are interested in exploring the 7.9C Readiness Practice for the proficient or advanced versions, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description. So our first shape actually has a section removed. We have a trapezoid that is the shape of a front lawn. We have a circular concrete base that is in that lawn, and we need to find out how much of the area is not covered by the flagpole base. So this is what we're looking for. We're looking for this area right here. This is a right trapezoid, and so we have two right angles here because it is a trapezoid. It's a quadrilateral with two sides that are parallel, only one pair of parallel sides, and it's got right angles. So we're looking for that blue section right there. So what we could do is we can find our area of a trapezoid. So that's the entire lawn. And then we subtract out the area of the circle. That's the flagpole base. And then that should get us what we need. And so let's first look at our area of a trapezoid. And so that particular formula is 1/2, and then your base 1 plus your base 2 times the height. And so it looks kind of like what we would do for an area of a triangle, except we have to add both bases. So let's take a look at what these numbers are. So our bases are going to be the pair of parallel sides. So what are the two sides that are parallel to each other? So let's label this bottom one base of 1. Doesn't really matter which one is base of 1 and base of 2. Let's label this top one at base of 2. Now we need our height. Now our height in a regular trapezoid is going to be an imaginary line because you have to have a line that's perpendicular that connects the two different bases. In a right trapezoid, you can actually use one of the side lengths. That 14 feet, since they're perpendicular lines, actually connects the two. Okay, so we can use that. So those are the numbers we need. So we're going to take 1/2 of 16 plus 23 multiplied by 14. All right, so let's start simplifying. I want to take my 1/2 of 14. That's going to be pretty easy, right? We can use the commutative property to kind of rearrange the order here. And I'm going to make that 7. And then I'm going to do 16 plus 23. That is 39. All right, so let's do 39 times 7. That is going to be 63, 21, 27. All right, so 273 square feet. That is the area of the entire lawn, including the circular base. Now we got to find what that area is to get rid of it. So area of a circle is, remember, pi r squared. All right, so they don't give us the radius. The radius is the distance from the center of the circle over to the side. And so let's do this right here, and let's say it's going to be right here. Now, they don't give us any measurement, but if we were to rotate this, right, so I'm going to erase this. Sometimes you can draw the radius in any direction. Watch what happens if I draw it in a different direction. What if I draw a radius here, and then a radius here? So basically what I've done is I've created a diameter, right? Well, I already have that distance. That's 14 feet, which means my radius is going to be just half of that. And so half of that is going to be right here, 7 feet. So we could use the information already given to us, and we can say, all right, if the height of the trapezoid is 14 feet, and that is perpendicular to the two bases, the radius of that circle that stretches all the way across is going to be half of that, 7. So it's going to be, let's use 3.14 for pi, and then we're going to use 7 squared. So basically what we're going to do is we're going to do 3.14 times 49. All right, so let's just go ahead and multiply by 49 right here. And we just want to round to the nearest hundred, so we'll just use the 3.14. And so let's go to 9 times 4 is 36. 9 times 1 is 9. Add 3 is 12. 9 times 3 is 27. 28. Let's do our second row. 16. It's 4, that's 5. And then that's 12. Let's add this up. So that is going to be 6, 8, 3, 13. That's a 5. All right, so I've got 153 and 86 hundredths square feet, approximately. We're using an abbreviation or approximation for pi as 3.14. So now I just need to subtract the two. So let's do this. If this is our area of a trapezoid, so I'm just going to underline that. I'm going to put that right there just so we can kind of keep track of it. And this is our area of a circle. I just need to subtract the two. So 273. Now I'm going to put a decimal right there because watch, you want to line up the decimals. And since there's blanks up there, I need to add zeros because I am going to need to regroup. So that's going to be 10. Take 1, leave 9. There we go. That's 4. That's 1. That's going to be 9, 1, and 1. All right, so it's going to equal, final answer, approximately 119.14 or 14 hundredths square feet. And let's get a big box around this as our final answer. All right, for number 2, we have a shape, and it is a square, a rectangle, and a parallelogram all put together. Now we do need to add all of these shapes. We can use the additive property of area, which means if we find the area of each of these individual shapes, since they are adjacent to each other, there's no overlapping areas, we can just add all three. We can find the total area of the shape, which is what we're looking for. So let's find the area of a rectangle first. So that's going to be base times height, length times width. If you want to use it that way, that works fine. And so my base is going to be 10.5. My height, I don't have a height, but I can use this distance over here because that's the same distance, 4.5. All right, so let's do a little bit of math here. 10.5 times 4.5, and that's going to be 25. That's 0, that's 2, and that's 5. And then let's get 20. And that's 0, that's 2, and that's 4. So that's going to be 5, 2, 7, 4. And I've got 2 digits behind the decimal, so I need 2 digits behind the decimal. So that is going to equal 47.25. And we are dealing with inches, so let's put inches squared. So I'm going to put that there, and then I'm also going to put this down here because I'm just going to end up needing to add all of these together. So let's just go ahead and start making this giant row. Now, I have a square. It looks like a square, but you also want the problem to tell you it's a square, which means I don't only have one side length, but that's fine because it's side times side, base times height, or side squared. Since each side length is the same, so it's 4.5 squared, or 4.5 times 4.5. So let's do that. Let's multiply 4.5 times itself. All right, and so let's zoom in a little bit here. So 4.5 times 4.5, that is going to be 25. And that's going to be 20, 22. And then let's get that 0. That's going to be 20. 16, that's 18. And that's 5, 2, 10. All right, so 20.25. I still need those 2 digits behind the decimal, so 20.25 inches squared. All right, so we've got 2 of them down. Now, our parallelogram, you might think it's going to be different, but it's also going to be base times height. So think of the parallelogram as just a slanted rectangle. That's why we have this dotted line right here. That's 2 inches. We have to know what the height is, and we can't use the slanted side. So that's going to be pretty easy. Um, we're going to use our base as the distance here. And so we can use that right there. That's 10.5. And then what is our height? Our height is perpendicular to that, so we need this right angle, and that's going to be 2. Notice that we have an extra side length over there we don't need. That's 2.5. That's that slant height, and we don't need that. But if you were to do this on the star test, it would probably give you that as a distractor because you don't need a slanted line. And so let's just double 10.5. And so if we double 10, that's going to be 20. If we add 0.5, that's going to be 1. So that's going to equal 21 square inches. All right, so let's bring down our 20.25 and then our 21. Let's make sure we line that up correctly. We can put a decimal there if we want to. And so this is going to be, we'll put zeros there if that's going to make us feel better. 5, and that's an 8, and that's an 8. All right, so to calculate the total area, we can say it is going to be, we could drop that 0, 88.5 square inches or inches squared. That is the total area of the shape. For number 3, now we have more of a area missing. So we have a tabletop, looks kind of like a pool table, except it doesn't have pockets in the middle. And they're 4 quarter circles. And what we need to do is we need to find how much felt is needed to cover the top of the table. So that means we're using this area right here. And so it's the whole rectangle minus those quarter circles. That's what we're looking for. All right, so we can say the calculations we're going to need are going to be the area of the rectangle minus the area of the 4, I'm going to put 4 QC, the 4 quarter circles. Now, the area of the rectangle is going to be pretty simple. Let's imagine our 4 quarter circles, okay? So if I were to take this quarter circle, so just imagine it with me. If I were to take this quarter circle right here and move it all the way over here, guess what I would get? I'm going to get that right here. All right, so now I've got a semicircle. If I were to take this quarter circle, move it down here, I would get that right there. And if I were to take this quarter circle and move it down to this open spot, guess what you have? You have an entire circle. 4 quarter circles makes one whole circle, just like 4 quarters make one whole dollar. So instead of looking at this as like 4 quarter circles, how about I just reimagine this as the area of the circle? So really, it's the area of the rectangle, and we're going to subtract the area of an entire circle, and they just cut the circle into 4 pieces and put them in the corners. So I know the area of a circle, that's pi r squared. If not, we would have to divide that by 4 and make it a little bit more complicated. So let's imagine that as the area of a circle. Now the area of a rectangle, it's going to be base times height. So let's say base times height. But what we don't want to do is the base is 20, but we don't want to say the height is 4. The height needs to be the entire height. And this is 4 inches is only the distance between the quarter circles. What do we know about the quarter circles? Well, that's back up here. Each quarter circle has a radius of 3 inches. All right, so that means from here to here is 3 inches, because that's the radius from the center to the side. From here to here, that also has a radius of 3 inches. So if I put those two radii together, I've got a 3, a 4, and a 3. I've got 10 inches. So we have to notice that our height is 10 inches. But once we get that, that's pretty easy. 20 times 10, it's going to be 200 square inches. Now I need my area of a circle, because remember the 4/4 circles makes an entire circle. So that is pi, let's use 3.14 times radius squared. So 3.14, my radius was 3. So really that's just going to be 9, right? 3.14 times 9. So that's going to be 36. That's 9, that's 12. 27, 28. Two decimals behind, or two digits behind the decimal. So call it 28.26 square inches. Now I need to just subtract those two. And so we need to add a decimal point after the 200 so we can line them up. 28.26. We're just rounding to the nearest hundredth. Remember that number is irrational, kind of goes on forever, because pi is irrational, goes on forever. Lots of regrouping here. I'm going to take 100, leave 1, and break it up into 10 tens. Take a 10, leave 9, break it up into 10 ones. Take a 1, leave 9, break it up into 10 tenths. Take a tenth, leave 9, break it up into 10 hundredths. Now I can finally do this. So I've got 4 hundredths, 7 tenths, 1, 7 tenths, 100. So I've got 171 approximately and 74 hundredths square inches. And that is our answer for the area of the rectangle, subtracting from that the area of the 4/4 circles, or the 4, or just the entire circle. If you're interested in exploring the 7.9C readiness practice for the proficient or the advanced version, or the readiness practice resource aligned with any other standard, you can find those by using the link in the video description.